Hey everybody, we've got a Sanyo PLC-XM150L to look at. This particular one was sent in, it says removed DOA. There we are. Oh, not 1501, 150. It's a PLC-XM150L. It's a 3 LCD projector. It's an older one, pre-HDMI. You could tie in HDMI with an adapter here. It's bright. I think they're like 3,000-4,000 lumens, something like that. It uses a POA LMP 136 lamp assembly, I believe. I'll show you. LMP 137. These have a chip. That's weird. That is not from the factory. Very interesting. This is here because it has no power. I'll show you. Now, this model, even with the door open, we will get standby. Does not need to have the door closed for standby. We can even push on the we get something to push in that. I can push on that little door switch just to show you. So we got nothing. The other thing we can do actually, which is kind of cool, and take this door off, is right here. So in here, there's actually a little metal arm that if I do that, it pushes the arm over and actually locks the door switch in. It lets you test it. This is weird though. Oops, sorry. That washer is not meant to be on there. So something janky is going on. We didn't put that on there. I know I didn't put that on there. The folks actually sent a bunch of their other lamp assemblies, and they asked about checking the lifespan, so I'm wondering if somebody's been moving some timer chips around. We might have to test these because this is a, you know, that's a wood washer. It's not for a projector lamp. Interesting. All right. Yeah, they broke part of it too. Somebody was in here messing with this. So for disassembly, the first thing I'm going to do is take the lens out. Just makes easier moving the projector around without that heavy lens. And there's a shutter over the LCD stuff, so I don't have to worry about dust getting in there. So now let's take some screws out. The screws, it should just be these ones around the top. I think I have to take those nuts out. Should just be, let's see, that's just an element filter, okay. Oh, I smell burned components. It's not super strong, but I smell something. I kind of wonder if these guys were messing around with the lamps, trying to trick the projector or something. You can't do that. These particular lamps have a microcontroller that sets the time, and you can't do anything to fool it. Like, that's just how it works. Alright, then that off, and then we have 1, 2, and then the cover should come off. So these two right here. Alright. Then lastly, Oh, that one's not long enough. Where's my... There it is. I use 2 drills. One I usually keep a thinner tip in, but I didn't. Come on. There we go. Oh, come on. We got an arrow here. I actually don't know if that one has to come out, but since it had the arrow next to it, I figure let's just be safe. Now let's see. There we go. Think it got a little dirty? Just a little bit. Man, that fan, that's alright. Not great, but it's okay. That fan feels okay. We gotta get way down inside if I remember. But I'm kind of thinking we'll just pop this metal cover off first and we'll do some voltage checks just to see if there's anything. I didn't hear that little squeal that power supplies make when you first plug them in, so I kind of feel like this thing's probably got a very blown power supply. Yeah, somebody else was in here. This got bent. That's been pushed on. They must have had the cover off, probably looking to see if there's anything simple. And there wasn't. Because these are not simple. There we are. This one. And this one. Alright, I don't see, that's just dirt. I don't see any burn marks. Nope. Do see some heat spots around that regulator. Come on. Alright. So power comes in here, I think. I'm pretty sure this is power. It's all lens stuff, fans. Yeah, I'm pretty sure this is power. Unless that's going to the back panel, which I guess is possible, but I'm pretty sure this is power. This is all lens stuff, so it's not that. Yeah, it's got to be here. Let's get the meter. Let's plug that in. Yeah, I didn't hear that little tick, you know, that you should hear. Let's go to volts. You guys can see that? Yes, you can. Alright, so I'll grab a ground here, and let's just go this fuse. Nothing. 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 Just going to go to all these little test points. I don't think we're going to see anything on any of these. Or not. Nope. Yeah. So we need to get down inside more. So let's unplug this. And let's see, the best way to do this. These, I don't like unplugging LCD cables, but this isn't an Epson, so it shouldn't be too bad. Then I'll unplug these. I'm going to try and leave as much plugged in as I can so that we can flip the board that way. So like this stuff will have to be unplugged. But everything else should be able to stay now. No, that too. Let's unplug that. Alright, so screws holding the board down. That would be this one? No? This one? Okay, it's a start. Oh, interesting. Look what I found floating around inside. Found that down there. That's interesting. Not good. Let's get this fan out. I'm taking the fan out because I want to be able to get underneath. There we are. Let's get that out. Alright, let me show you. You see that right there? We got Mr. Fuse. So let's check Mr. Fuse, because it might just be that. So I'm going to leave the meter out of view, but we're going to check the fuse here for continuity. So let's see, let's get right there. And then just listen for the beep. If we hear the beep, so the fuse is good. I was really hoping that fuse would be bad, because that would mean that we could just try swapping the fuse, but that means we're getting 120 volts inside and that's getting lost somewhere else, so let's keep going. I am not a fan of the parts canon, so I always want to troubleshoot, see if I can figure out what parts are bad and then fix it properly. Let's unplug these so that they don't get caught. They don't want to bend. Alright, that's good. So we need to get down in here. That's where we're headed. Let me just put this back here that helps support that. Okay, so let's get that out. I remember I have one of these, or I have a 4500, and the 4500 had a problem when I was testing chips with it. I accidentally shorted out the 6 volt or 5 volt line or something. It damaged the 6 volt rail, and I had to fix that. That was fun. Without a schematic, of course. And I forgot to put this piece back in when I first put it back together. So I'll always remember that. Here's the ballast. Let's get... Come on. Oh, dang it. I just dropped that. Oh. There's a washer down there that I didn't get. I'm going to have to get that. We should probably check the ballast too while we're in here, because we don't know what damaged it. Alright, let's unplug the lamp wire, get out of the way. Alright, one more screw. Ushio ballast. Trying to unplug the PFC. There we go. Alright, so now I should be able to... Alright. I'm remembering little by little of all the little brackets that need to come out. So like this one, that releases the wire. Then this screw, I'm hoping we can just lift that mechanism out. And then on the other side, I actually don't know if that one needs to come out to get this out. That may have just been through the board, but it does feel more loose now. And then there's going to be a couple on this far side. So there's one here, and then there's one here. There's one here, maybe. What is holding it? There's something binding, preventing this from coming out. Oh, wow, okay. What the heck is holding it? I feel there's got to be a wire. I should have thought of this. There's a temperature sensor or a temperature breaker fuse thingy that is fighting me. I don't want to have to take all that apart. Let's see, can I get it to move? Putting this back together is going to be a little tricky, and I'll show you why. Alright. How do I want to do this? Let's see, that's all zip tied.
2,000 years later.
Man, getting this wire out, this fan wire. Last time I did this, I unscrewed the fan from the power supply, and it was stupid. I mean, I'm gonna have to do it anyway, but it was stupid to do with it inside. So instead, doing it the smart way. Alright, unplug our low voltage wire, and there's the power supply. So this is what we're gonna look at. And this was that wire giving me a hard time. And here is another screw. I did not drop this screw. I did drop that washer because I was looking for that, but I did not drop this screw. So this is going to be the tricky part, getting it back together. Maybe I did take the optic assembly out last time. Maybe we'll do that when it goes back together. But for now, we're just going to fold that main board back into position and slide this out of the way. This is where I think the problem is in here. So let's pull this board out. I hope it's not this chip. I hope it's not any of the chips because they're kind of difficult to get. I do see a few things though that are making me think it might not be them. Let's see. I do have to take that out. Alright. I wasn't sure if this was holding or what, so there we go. Alright. Nothing blown up, obvious. Nothing obviously blown up, I should say. Caps look okay. No skid marks. We did check that fuse. Now let's grab the meter and do a quick test. Let me pull that heatsink off the top so that we can get in there. Alright, nothing obvious there either. The cap's okay, those caps are okay. Let's see, let's double check that fuse. Fuse is good, alright. Let's go to the bridge rectifier. So let's see. Okay, that's good. Interesting. What is that? That's right next to it. This thing. Let's see. It is marked DS401, but it's 3-pin. I guess that could be a diode because they're calling the FETs Q. So DS, that might be a SCR, I guess, possibly too. What we got going across there? We got a PTH, so it's a thermistor probably. Yep, that's going to here. That's ground. Man, that just seems, I don't know, that just seems off. This is positive right here. Let's check these MOSFETs. No shorts. That's protection diode, no shorts. This thing's weird, this DS401. I do wonder about that. What else? I'm trying to see if there's any secondary fuses. Little 0-ohm resistors acting as fuses maybe. But this, I do wonder about that. Let's go to resistance and see what it's measuring. Because an SCR, I think I should get like 50 ohms one way, if it's good. 126 ohms, 10 ohms, 135 ohms. No, alright, that's good. Yep, capacitor's charging. Oh, you know what we didn't check? I should have checked that, that thermal thing inside the projector that was plugged into here. That could have interrupted the power. Did not check that. Set that power supply off to the side. Let me drag this over and we'll check that. Let's see, we should get continuity if it's okay. Yeah, alright. Wishful thinking. I was hoping that would be the case. Alright, well, let's get back inside the power supply. I got the service manual for this because the whole layout was kind of confusing to me. I wasn't quite sure what was going where. I do see that there's a 5-volt relay, and I also had that, whatever that part is measuring a little weird. So I figured I'd grab the service manual and we can see what DS 601 is. But the first thing we're going to check in here is the standby supply, the low voltage. So over here, these two lines going off the page, let me just make those more obvious for you. So that's AC in. So we have our line voltage, in this country it's 120. So 120 volts AC is going into these 4 diodes, which is a bridge rectifier. And then this is ground, negative. And then that's positive. There's a 450 and 150 volt cap. And then this is the switching controller that creates the low voltage on this side, which is used to trigger the relay. You can see there's the relay. And then there's the rest of the power supply. This is this section. So you can see power comes in here. We got some filtering. There's a thermal breaker right there, I think. Trying to look at it from the side, yeah. And then AC splits off into the PFC circuit. This creates the high voltage for the ballast, but it's controlled by up here. So when that relay is turned on, it sends power into this main rectifier right here. So there's 4 diodes, D618 right there, 621 right there. So they're just doing a half wave. Wow. I wonder if that's what those X's mean. Those X's probably mean they're not always used. So this is doing a half wave rectifier. So that one's not there, and this one's not here. So it's just those two, but it doesn't matter. We still have positive up here. It's just choppy. And then the chip, IC603, that's this guy right here. So I'm wondering if this 4.7 ohm resistor is bad. That is, see, here's VCC to the chip. There's a D616. I guess that's a bootstrap circuit. And yeah, that's probably what that is. So we want to check that D616 and then that R623 and see if they're okay. There's a chance that that chip is bad, but I don't know. So we're going to check the components first. If the components check out on the meter, then I'll hook some power up to it and we'll check it that way. So first things first, let's see, let's check the diodes. I'll go on the other side of the camera so don't have my hands in the way. So we'll check these guys first. I'm sure they're fine. Yeah, that one's good. That one's good. Let's check from okay, so that's that. So this neutral. Yeah, alright. So we have hot and neutral. They're good. And then let's see, so that diode that I'm questioning is D616, which is this guy. That's 613. 613 is somewhere else. I don't see 613. Ah, I see. 613 goes, this is the protection for the relay. So that's protecting the relay. That is the transformer T652. Yes. There's D617. That's drain and source, maybe. Yeah. Alright, so then where is D614? I want D616. That's what we're looking for. On the bottom, maybe? Yep. Yep, that's good. I have a feeling that's going to be good. I'm sort of questioning the chip. Let's check that resistor too. The resistor looks okay. Yeah, that's fine. Alright, and let's just see if we have any resistance on that coil for the relay. Yeah, that looks about right. Alright, I'm going to pause the video. I'm going to rig this up so we can test it with some power. So I have this now set up for testing. I bypassed the thermal switch using just this jumper. I have my little dim bulb tester plugged in to limit current. This should be all we need for checking it. I do see that on here we do have two wires that go to power switch, but it looks like we should still have that 5-volt output there. Yeah, we should have that 5 volts that's showing right there. So that is on, is that pin 6? It's pin 3 or pin 6, I guess. We'll figure it out. Actually, it's two of them. F34. Let's see. Is that F or is that L? Am I reading that right? L615. Ah. So this guy right there, we should have 5.5 volts on that right there if this is doing anything. So let's put that here. Let's put the meter here so you guys can see it. Let's turn the light on. Oh, you can't see it. Alright. So then, first thing I'm going to do is I'm going to check the bridge, or that half wave bridge. So I'm going to go on those two. Actually, maybe we'll go across that capacitor. Let's go across C642, which is this guy right here. So on the bottom, we're going to go across these two pins. So turn on the DBT. So there's now 120 volts. Oh, there we go. I guess I wasn't getting a good enough connection. That was a little weird. Alright, there we go. Okay, so now we do know that's coming in. So we should actually, let's go. let's go to these two diodes. So we should again have 112. Good. So then if we go to the other side of those diodes, I should 150. Okay, so that's coming in. That's good. Was that, did I have that polarity the right way? Okay, so this is our negative. So let's go to our capacitor, 150. So then, so we have 150 across here. We'll check on that chip. So from pin 8 to pin 3 should be 100 and something. So that's this. So pin 8 and ground, 150. VCC is pin 5. This guy, what do we have? 9 volts. Interesting. Very interesting. Let's see, do we have anything on the, no. So this is the relay. One side is ground. This side. So from here to here we should have something, and we don't. Oh, okay. I was wrong. We shouldn't, because the 5 volts is fed into here, so we wouldn't have 5 volts there. We would have that 5 volts elsewhere on, let's see, where is it? Q613, Q613, 612. Let's see, that's coming over to here. It is. All right. So there's a little surface mount fellows. We should have 5 volts on one of those if we're getting, if this power supply is running at all, and it doesn't seem like it. I feel like we should see, this chip may have failed, but we should see on pin 7, why am I getting nothing now? Did I unplug something? Now we're getting nothing. 150, okay. That's weird. I should be getting 150 here too, from this ground to there. And let's see, what is ground on this chip is going to be pins 2 and 3 are sharing ground. We'll just grab the ground on that side of the capacitor. Nothing. 150 volts. Wow, we're not getting ground. Let me untake the power off. So, what I'm whining about is that when I measure from this ground to here, no, that actually makes sense. Although they have them marked off both as ground. That can't be right though. That's because that doesn't make sense for voltages, or for the way that we, yeah, okay, that makes sense, or makes sense enough. So pins 4 and 5, D616, that's this guy. So we did have 9 volts for the VCC, which I think is right. We had, so we had 9 volts here, and that capacitor is a 450 volt. Where's that little cap? C640 right there, this guy, and that's 50 volts. So yeah, that's fine. I'm trying to see if that chip looks burned at all. I kind of think this is the problem, this chip, because I don't see it switching. When it's powered up, we should see it switching. So let's see on the output, C635, is that big guy? Where's C635? 16 volt. So C635 is the part that I'm looking for at the moment. C665. C683, 681. Just trying to find the capacitor so I can check that. Well, I'll just do it from the top. It's fine. All right, let's get this cable this way. All right. So we're going to check. Let's check that output there and see if we have anything on this bead. This L615. Nothing. I don't think this is running. Yeah, I got nothing on any of these. We should have something. So I'm really leaning towards that one chip being bad. Make sure that's tight. That was a little loose actually. So let's see. So D614, which is, where is D614? No, that's all right. Let's see what we got. Let's make sure we don't have that. We don't. Let's go back to this transistor. We got nothing. Yeah, so that's the turn on transistor. So we should have 5 volts on one of these pins, and we don't have anything. So I think it's this chip. Let's go back to that other ground. This 2 ohm. Oh, we got a 2 ohm resistor here, which is, what is that? R664. R664. R611. 644. So that is the, I don't know what that is. SOCP, I think, if I can read that right. But that's ground, and then a capacitor. Oh, I wonder if that's the bootstrap, like that's the startup, if that's where it gets its pulse from, through that cap. But that cap isn't used actually, it's got the X on it. Let's see, we'll go from ground to one side of it and see if we get anything. We don't. Alright, and I'm getting that from the other side, so that resistor is obviously good. It's not that. Yep, that's our 9 volts. That's what I expect. That's coming out of here. This is AC. Let's see if we get, see if I can get anything. What I get on that AC side. No. But that's working. That is working. Alright, well, so that's telling me that on the output, which in this case is pins 7 and 9, 6, 7, 9, got nothing. 1 and 2, we're probably gonna have 150 across it. Or, sorry, from ground. Nothing. Oh, duh. Sorry, I was on AC. I know I'm measuring a DC, well, a transformer with DC, but I want to see it's supposed to be a switching transformer. So we do, oh, interesting. Look at this. Oh, 1 and 2. Oops, not 1 and 5. So 1 and 2. Yep, 152.7. 52.5, so it's going in here, so that makes sense. Alright, it's probably that chip. I'm gonna go pull a data sheet on that chip. Alright, let's confirm something. I was just reading the data sheet on that chip, and it says that VCC needs to go over 15 volts for the chip to start. So there's a real good possibility that maybe that cap isn't charging up enough. But let's see. So this, I think, make sure I got the, yeah, alright, and you guys can see the meter, yep. Alright, so the startup was, what is that, pin 5, so 1, 2, 3, 4, 8.9. Why do I keep on not getting a good connection? Just want to see if it moves at all. Yeah, see how it's slowly creeping up? I wonder if that cap isn't charging properly. This guy right here. What is it there? 22 at 50. I think we should pull that cap out and check it. Could be that chip, but that cap is definitely looking weird. Not good. Alright, I've replaced the capacitor with a new 22 mic. Let's see. Make sure you guys can see that. Let's see what we got on there. I kind of feel like it's going to do it. Make sure I'm getting a good ground. Let's go. Look at that. 4.982. And that's without a load, so it'll probably come up a little bit. So what I'm going to do now is, let me shut it down, let's plug in the low voltage cable and see if we get the standby LEDs. So I just ran the low voltage cable out, just got it plugged in. The thermal switch is bypassed. I removed the LED display board, you know, the status display board from the cover and just plugged it in there. I got the meter, we can check the voltage, but if this comes on and we see the LEDs, then we know that that cap at least took care of that part, and that means I can put it back in the power supply and see what happens. So let's see here if we get standby. Hey, look at that. Wow. Yeah. There we go. And yeah, it's going to complain because I don't have stuff plugged in. Fans came on and stuff. But that's good. Fans came on, as you heard, or maybe you didn't hear, but a fan came on. But I don't have everything plugged back in all the way. I don't have the temperature sensor in here plugged in, don't have the LCDs plugged in, don't have power supply fan plugged in. I just wanted to make sure we would at least get that, which is good. Oh. No, actually that's good. We know that's alright. I was going to check the voltage, but obviously that voltage is fine. So the problem, that capacitor right there, is that the, yeah, that capacitor, C640 was bad. So let's put the power supply back in the box, see how we're going to put this all together. I may have to take the optical assembly out to get this back in, but we'll get there. Let me, let's get started on reassembly. First thing, let's put the heatsink back on, that extra secondary heatsink. And let's put these back in, and then I will, I'm going to blow out that chassis, that casing, because there's a lot of dust in there. Not as much as I've seen in other models, but it's pretty dusty. And these guys, we got to be careful how tight I make them, because these are aluminum threads and cheap steel screws, but they're strong enough to strip that aluminum out. There we go. Alright, that's back in. Let's get that out of the way. Unplug my little jumper. Put that back in its box. And then we're going to install it back into here. See, that fan looks good. Don't need to clean that. Okay. So that's going to go out this way. Alright, it's going to drop in there. And then we can still get to the thermal switch. That's the word I was looking for. So we'll be able to reach that through here. Because I was trying to see if there's a way I could do this without making a big to-do, but it looks like you have to. You have to do it that way. But that's alright. Let's put these screws back in. Driver, let's get this one. That one. Oh, wrong one. There it is. This one. Larger screw. That one, and then that should be all the screws for the bottom. So the other holes that are open, this one, yeah, that one, and this one, and also that and that, get screws going through the top. You can see that hole there, and then that hole, and that hole right there. So let me blow out the projector, and then we'll start putting all this stuff back in. Alright, so I looked at trying to get this out, this part by itself. It's fighting me. Lamp basket might be holding it. I did take out those screws and that, so it's like it should be loose, but I feel this front moving. So I think to be safe, let's just unplug the main board, and then we will go down inside and get all this open so that we can get the power supply back in. Actually, that one can stay. What do we got here? That one. Come on. We've got a couple. Oh, pardon me. I was hoping I could get away without cutting these zip ties, but that's not going to happen. There we go. Then on the bottom, on the front, we have these guys. We're going to leave that one connector because that goes to the LED panel that is just floating about. So let's just lean that back there. Alright, so I think if we take out that one and, pardon me, up. Oops, that one went loose. Oh, that one too. So this plastic has to come out. This is the lens lock. Yep. Now we should be able to lamp basket. Yeah. Now I'm going to try and not take the entire lamp basket out. Hopefully this will, yeah, perfect. I just want to loosen it so that we can lift this out. There's the optic assembly. LCD panels down in there. Got a little bit of crud. I think we'll get a brush in here and pull you up inside there too. Look at that. Alright, let me go clean this out and then we'll start putting things back in here. Alright, that cleaned up really well. That's good. Alright, let me set this off to the side and we'll get that power supply back in. Let's see here. The power supply went this way. Let's get our cables so they don't get caught. I do have to take the basket out. There we go. Wow, that was a thing. Now it's down. All right. All right, those are good. Let's set this back in its place so that we can Alright, so this has to stay loose for now until I get the optics back in, but let's throw this screw back in. Alright, one. Okay. One. Two. Alright, that is all those. Then this has to go back on. This goes over here. This goes here. That's right. So let's plug the ballast wire back in. Okay, that's good. So we got that in, that's in, that goes there. And we have to put this back on. And we'll route that wire. I really didn't even have to take this cover off, I don't think. But I figured just in case. Right, not that one. This one. Here's a big big thread on this side. There we go. It's pretty good. Alright, let's... a little bit of dust. There we go. Alright, so this wire... looks good. Let's get this stuff. Forgot to plug the low voltage in. It's got to get down in there, and I hope I can do this without having to take that all back out, because that was a real chore. Yeah, I'm gonna have to remove this plastic. I actually got it without having to pull all that out. I just kind of lined it up and then went around with the screwdriver and just gave it a little push. It's in there, no problem. Now I can put this back in. That was the whole thing. This goes here, you know, and then the screw holder, the little tab holds it down. Alright, so this goes in here. That holds the wire down. Actually, I think, because this wire pulled loose before I could see how it was set up, but looking at the wire, it's probably like that, with that little thing holding it down. And this was all looped into, oh man, I'm trying to, I think it was over, looped somewhere. I think it was, yeah, it was down here. Okay, so far so good. I think we can set that optic module back in. This guy, I'm going to keep going with reassembly. Hold it here. Alright, I like that. Let's get these in. Hold that metal bit. Once that metal bit is held in, then we're getting close. There we are. That's going to hold. That keeps everything in position for me. So let me put these two screws back in. Alright. Then all the rest of the case screws, or the optical assembly screws. see if I can do this without dropping it. Alright, good. So I can't really see. So I have to do it by feel, which is fine, I don't mind. It just leaves a little more room for error. So I just have to be a little more aware. Let's see this one. Beautiful. Alright, that's good. Those are in. Now let's put the lamp basket screws back in. This one. One. Two. Three. Plug the lamp timer connector in. There we are. Let's put this vent back in position. There's only 3 more for these guys. For this part. Let's put this plastic mechanism back in. It's going really well. I'm actually really happy with this so far. Oh, hang on. Almost made a big mess. Move that wire before I pinch it. Yep, looks good. I almost pinched that wire. I'm glad I didn't. There we are. Good. It's all good. Can't put that in yet. That's right. Got to put the main board in first. Let's get this back out. This gets screwed into a tab on the board, so let's do that. Last time when I worked on one of these, I made the mistake of not putting this back in first, and then I had to take it all apart to put it back in. So this time I'm going to put it in first. Okay, that is a nice start. Let's get all these in. Let's see, and what? That and that one. Alright, so this one. Just make sure I don't have any other screws I need to put in first. Let's see, that's going to go there and there. That one, so this one. And the rest of these are all held down by the screws going through the main board. Oh, that did not need to come up. Oops. Oh, wait a minute. Over here, this ferrite bead needs to have the fan inside of it. Oh, come on. Let's get some screws in. Hold this. Actually, I think we have to put this on first. You see which one of the screws I put in before I tighten that down. Oh, wrong way. Let's see. On this side, do we have any? No? Oh. Okay. So all those go in after these wires are plugged in. So let's plug in wires. lot of connectors. These are all temperature sensors and fans and all that sort of thing. These are so much easier than Epson. They're just straight connectors. It's not that double row compound connector thing. I don't hate working on LCD projectors, but I will say that fixing or putting this back together definitely makes me cringe. Alright, let's see. These guys go on the bottom. Let's get all this out of the way. These first. The customer said this thing's been down for months, and they were thinking about buying a new one and this and that, and then they decided to give us a shot. Figured they had nothing to lose. Worst case, they got to buy a new projector, and they thought they were going to have to do that anyway. Well, now we know the projector most likely is going to fire right up once I get this all put back together. I'm going to plug this in. We'll leave this just hanging, and then I'm going to put the screws in that hold that metal piece down, and then we'll plug in the lamp and try it. Alright. I think that's... oh. Almost forgot Mr. Fan. Let's get Mr. Fan. Yeah, that lines up there with that connector. Let's get this in. And then this one. And then I got the two on the bottom. Now I did find a handful of screws just kind of rolling around in here. So I don't know where those came from. So there might be a few screws left over at the end. Like, I'm not quite sure where this one came from. Oh, where that one, that's a big one. To me it looks like they're all dealt with. So I don't know. You know, I didn't see any openings, so we're just gonna be careful. We're gonna see what we got. Let's see, is that a... Actually, I see a spot where this might go. To the left of the main board, there is an opening. Yeah, there's one more. There we are. Sorry, I thought I hit record and I didn't. It is... if I can get it so you guys can see it. down there. Alright, make sure they're behind. Okay. That actually looks alright. I'm not going to run those in all the way. I'm going to put them in most of the way. Oh, that's the top. Alright, so I don't put them in there. Once I get enough of these in, then I can start snugging them down. Like that one. This has enough wiggle room to get everything to line up and for the screws to go in. And this is the next to the last step before we test it. After I get these screws in, we'll install a lamp assembly and see what happens. Should be fine. As long as the PFC comes on. Maybe we should have checked that. Well, maybe. Probably. It's alright. Alright, and then 1, 2. And then we'll give it a once over. Oh, wrong screw. There we are. Alright, let's see. 2, 3, 4, 5, 6, 7, 8, 9. Looks good. So we have a switch down here. We'll have to put those screws back in once the cover goes on. Yeah. But for now, let's let's get a lamp and see what happens. Alright, they sent this. I actually don't know if this lamp is any good. They actually sent a bunch of lamps and they want me to check them and see if they're okay. They sent 2 projectors. This actually might be the lamp for the other projector, maybe? Yeah. Need a 136 as a 137. Alright, let me go get a lamp for this. Here we go. POA LMP 136. Among other names, they have all kinds of oh, come on. Oh, did they break the connector? They did. Wow. Okay. I'll show you. See that right there? That's the lamp connector. See that? I shouldn't be able to, I don't want to push it too much and make it worse, but it shouldn't do that. The little tab on the side snapped off. What I'll probably do is epoxy it once I know it works, because I'm not replacing that wire unless they really want to pay for it. Those are expensive. Those connectors, oops, that connector, my cost is around $100 because the cable has a transformer, an ignition transformer in it, so that will not be a cost-effective replacement, especially if I can just epoxy it. You know, this is an older projector. We're not going to go nuts on it. This is already going to cost them enough. So, but connectors in, chip is down, wires are in. I'll replace the zip ties over here before I put it all back together. I just want to see it all work first. Let's get power. No booms, good. Or smoke. We have our standby. I think we're good on the door. As long as we don't get all these flashing together, I think we're okay. We're in standby. I'm just going to get ready to yank this in case I have to. Just going to hold that power cord. And let's see what happens. Nothing. Did I not hit the power button? Hey, there we go. I guess I didn't hit the power button. Keep watching. See if that lamp comes on. I don't see the lamp yet. I did not check that 150 or the 300. Oh, hang on. My fault. I have the door switch off. I'll show you that. Hang on. Let's just pull that. So normally, when the door is on, it hits this little switch to tell if the door is closed. We were going to get a lamp error soon. And I still don't know if the PFC, the power factor correction, is okay, but we're going to find out. What's nice about this particular model, and a few of these, is it has that. So if you're on the outside, you get in there with the screwdriver and you can move that little test switch back and forth. But now it's going to think the door is closed. So let's spin her back around and see what happens. Wait for our standby. We got it. Down all the way. I heard the shutter open. No lamp though. With the way that connector is, I do wonder if that ballast got damaged. Now we have power again, so the thing's trying to come on, but we're not getting any lamp. Now I don't think we have to get all the way back down to that power supply, at least the same one, but we do have to get near there. let's just see what happens. I'm going to let this run for a bit. Everything looks okay. Just waiting for us to get a lamp error or some sort of state change. Alright, there we are. Lamp replace. Lamp did not try to fire, so we do have to check the ballast. So I'm going to take this stuff off and get back down to the ballast. You guys don't have to watch me do that. I wasn't going to show this because I thought I was going to be troubleshooting more, but I found that guy wasn't plugged in. That needs to be plugged in. There's no power if that's not plugged in. So let's plug that in, and then we'll slap this back together enough so that we can try it. There we go. Perfect. Be right back. Alright, PFC is plugged in, mainboard is set up. We're going to try it like this without the metal cover on. Doesn't matter. Let's see what happens. If we don't get a light this time, lamp light. Oh, wait a minute. Almost forgot to plug the LCDs back in. I'm going to plug these back in, but if we don't get a lamp this time, then I'm going to need to investigate the ballast and the power factor correction circuit that drives the ballast. But not having the wire plugged in will definitely do it. 100%. Okay, let's try this again. Get you guys up a little bit. What am I not doing right here? Everything else looks plugged in. Hey! Look at that. You guys see that? Sanyo! Sanyo! We have light. This is great. So, as soon as this boots up all the way, I'm going to shut it down. And then we'll get the metal put back on, get the cover on, da-da-da-da, and then we'll go and do the big test on it. It's got to wait for it to count down. That little blurry spot there, is it counting down? There we go. Turn it off, let it cool down. This is great. Let's start putting it back together. Let's get this metal cover back on. I know that... Oh, actually no. I'm going to put the cover on off camera because you guys already saw that. But what we are going to do... Let's get our zip ties back in there. There's a opening. That is not a screw hole. Right here. And then let's put one back. Oops. There we go. This didn't have one back here, but I feel like it's a good spot for one. Just kind of keeps all those wires a little more grouped together. Oh, oops. Did not mean to do that. Can't zip tie this one in. I mean, I guess I could unplug it there, but it wasn't zip tied originally, so we're not going to zip tie that one. So instead, let's do it this way. There were 2 zip ties, if you remember, but I think we can get away with, might get away with 1 here. Let's see. No, let's do 2. It'll look better because that one holds down those little wires on the underside connectors. So let's put, come on, there we are. This one here, come on. There we are. Alright, that's good. Now, I'm going to put the metal back on. So this is my test projector, this Panasonic. You can see the inside is essentially identical. Panasonic bought Sanyo back in 2012, so kind of makes sense. But I noticed this screw was missing in the Sanyo, so I looked in my parts bin and sure enough I have one. So let's do that. That's to help keep that little switch in position so that you don't accidentally bump it on. And that's going to go here. Actually, let's turn off. Let's turn that off first. So now we need the door for it to come on. Otherwise we'll get an error. So let's put this screw in. There we are, and that should keep this from getting bumped. It will. That's good. So then we still have the internal screws to put in, but we can put the cover back on like this. Actually, this is the lamp door. Let's put the LCD cover back on first. This piece, it just kind of slides in there. You catch the grooves, put that wire down and slide her on back. Let's tighten that. And then are actually there we are. I used to set it down to 1, so it's very unsnug. See, I can just, that's good. Alright, so now let's do the rest of the screws and then we'll take it to the other side and try it. I'm curious to see what screws end up being left over, because I did find some rattling around inside and I don't see where some of these would have come from. I'll show you what I mean after I get the rest of these in. Let's see, so we got this one. No. No, see, they're supposed to be fine thread. So I have these two left over. And then this weird looking fine thread. It has like a taper. So I don't know where that one came out of. But let me go in my screw bin and get 1, 2, 3 fine thread screws. Okay, these are good. Let's get this one in. And last but not least, there we go. And while I'm back here, let's give this a little spritz and clean. It is ceiling mounted, obviously, so this part faces up. I'll probably wipe the top off too, but let's go ahead and set this up. Let's go set this up over there, and we'll see what it looks like. Alright, it's not quite on the screen. Like that. We're just going to have it a little off the screen. Let me get the image up. So I have my little DTV box hooked up. Have it searching for channels. It's probably not going to find any. But this is just the source I'm using. Alright, we're inside the menu here. Let's see, I did put a new lamp in. And let's see, 0 hours. Now this is not focused because I don't want to change their focus settings. They have it mounted in a spot and leave well enough alone. I can see that this is okay. So yeah, we have power, we have lamp. I'm going to let this run for about an hour just to make sure everything's copacetic, but I'm happy. One more thing to do before we wrap this up. I'm guessing when it broke, they wrote this on the back in Sharpie, removed from something DOA. Let's get the rubbing alcohol and see if we can get that off. Wow. Yeah, I don't really like writing on projectors directly. It's not very good for them. That ink gets down into the, you know, the surface. Maybe what I'll do is I'll soak it, or I'll just leave it like that, because I tried to get it off and, well, you can only clean it so thoroughly. Let me just wipe the rest of it down while I'm at it. Man, I wish I could get that off. That's bugging me. Oh well. It's fine. So there we have it. That's how to repair the power supply on a PLC-XM150L. Also how to tear down and get to the different bits and bobs. So if you have any questions, go ahead and stick them down in the comments. If you need a replacement lamp assembly for one of these, go ahead and click that link. Get yourself one of these for yourself with the Ushio bare bulb inside. Very good lamp, very good timer, and all that fun stuff. So if you got this far in the video, I really appreciate it. Think about hitting that subscribe button, the like, whatever, share, YouTube, blah blah blah. But really, most importantly, as always, thank you for watching.